In order to get ready for the water quality project you'll be working on next week, you're going to spend some time today calculating biotic index. So this is what you'll be doing next week when we go to the river. We'll be gathering our information and using that information to take some measurements on the overall health of our river. And so to do that, we do what's known as a biotic index. So just to kind of go over some of these points of this document, and this is what you have. A biotic index is just simply a way to show quantitatively, meaning using numbers, a way to show health of a river by looking at species. In this case, we're looking at what are known as macroinvertebrates. So we spent some time on Thursday identifying different macroinvertebrates and just kind of looking at their characteristics. And so we use either the presence or the absence of those macroinvertebrates to get a gauge. In that case, our gauge is really our water quality rating with excellent, good, fair, or poor, based on a couple things, based on how many we find and based on what species we find. And so because the presence of these different species tells us something, they're known as bioindicators. Think living indicator. They give us an idea of a bigger picture. In this case, we're looking at overall water quality. We look at what species are present and in what numbers, or meaning in what abundance, are present. So we're looking at these. They're known as bioindicators. We talked about that on Thursday, but we're just going to revisit that. There's going to be certain species of macroinvertebrates that can only live in environments that have good parameters, meaning the temperature is within a normal range, the pH is not too acidic or too basic, there's enough oxygen available. All those different things have to be in place in order for these species to survive. So if we find those species, it kind of gives us an idea that these other parameters, these are the non-living or abiotic parameters, are good. And so you'll be working with how to calculate that and quantitatively say, meaning with numbers, be able to say, is our water quality, good, excellent, good, fair, or poor. So there's two different ways to do this. There's a simple biotic index rating, and I'll walk through an example kind of showing you how to use this, but the directions are all laid out here. And there's a more complicated index rating called the weighting factor. And so kind of big differences here is your simple biotic index rating is simply just taking into account how many organisms you have. So that gives us, we talked about here, the total biotic index value. So that just tells us how many were we able to find, how many different species were we able to find. So in this case, it tells us good water quality is indicated by a variety of different kinds of organisms, with no one kind making up the majority of the sample. So in this case, we're looking at the more diversity we have, the better health we have, we can say, within that river. So I'll walk through an example to show how we get these scores, so that how we relate these different ratings to our river. So to walk through an example, I have some sample data over here. So it gives us, these are species on the left-hand side, and this is the number that we were able to gather from a sample. So this is just some example data. So if we want to look at the simple biotic index, I'm going to walk through the steps of what to do. So the first step here, if we look at the document that explains this, is to count and identify species of macroinvertebrates. We have that. We have our species and we have our numbers. The second step is to assign numbers based on abundance. So it says assign a 1 for any count of 1 to 9 organisms. So what you can do is just put numbers right in the box. So anywhere, any species that have between 1 and 9 organisms, you write a number 1. In this case, assign a 2 for any count of 10 to 99. So in this case, 28 falls between 10 and 99, so does 18, and so does 88. So those values would all be 2. And then assign a 3 for any count of 100 or more. So that would be this one. So once we've assigned those numbers, we just simply add them together. So we have 3 plus 1 is 4, 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10, 10 plus 1 is 11. And if we look over here, we can see that that number 11 falls within that fair category. So then we would say that this water quality would be fair. Again, it's looking at diversity of species and looking to see that this river isn't dominated by just 1 or 2 species. So that's how the simple works. Categorize your numbers based on how many there are, and then add up those values to get an overall rating. Compare that rating to this table, and that gives you your category of excellent, good, fair, or poor. So go ahead and try the examples and those practice problems using the simple index, but moving on into how to calculate index using the weighting factor. So this is a little bit more complex. There's a few more steps to take into account, because one thing that this calculation takes into account is pollution tolerance or pollution sensitivity. And so if we look at the first line, takes into account pollution sensitivity. Are they sensitive? Are they somewhat sensitive? Or are they tolerant? And it takes that into account in addition to the number or abundance of each species. And so what I have is species are already categorized into what category they fall in. So this is at the bottom of that document. It tells us that these species are sensitive to pollution, these are somewhat sensitive, and that these are tolerant, that they can be in any quality of water. We could find them in good quality, we could find them in bad quality. So you have this available to you, so you're not expected to know where they fall. But what we want to do then is work through a practice problem using this weighting factor as our way of calculations. And so first thing we want to do is classify our species into, are they group 1, 2, or 3? Group 1 being sensitive, 2 being somewhat sensitive, 3 being tolerant. So how we do that is I have this table already added to the document. So if we look and we look for crane fly larvae, we can see that crane fly larvae fall into the somewhat sensitive category. They're right here. So one thing you can do is just write, they're in group 2, write a 2 there. If we look, oops, put it in the wrong box. 2 should be up here. The second one then is caddisfly. So if we look at caddisfly, we can see caddisfly larvae are in the sensitive, so that would be group 1. If we look for stonefly, we can see stoneflies are in the sensitive group, so they would also be in group 1. If we look for pouch snails are over here and tolerant, so they'd be group 3. Crayfish are going to be in group 2, and scuds are also going to be in group 2. So the first thing you want to do is classify into group 1 being sensitive, 2 being somewhat sensitive, 3 being tolerant. Once we have that, then we want to calculate abundance. So in this case, this is where the rare, common, or abundant comes into play. And so, again, if it's between 1 and 9, it's rare. So we know our caddisflies would be rare, so we can just put an R there. And we know our scuds would be rare. We'll put an R there. If it's between 10 and 99, that tells us it's common. So that would be our stoneflies, our pouch snails, and our crayfish would all be common. And if it's 100 or more, we know it's abundant. So our crane flies then would be abundant. So what we do with all that information is we work in these weighting factor values. And so it's based on group and it's based on abundance. So we're down here at part C. Add the number of RCs and A's in each of the 3 population groups. So this is what I like to do. I like to organize it, and I'm going to look at group 1, I'm going to look at group 2, and I'm going to look at group 3. And under each group, I'm going to write an R, a C, and an A for rare, common, and abundant, so that I have an easy way to keep track. And this is just how I like to organize it. So if we go all the way down, we can see that group 2 is abundant. So we put a tally mark next to that. We know it's done. Group 1 has an R. Group 1 has a C. Group 3 has a C. Group 2 has a C. And Group 2 has an R. So we just want to categorize of each groups, 1, 2, or 3, how many R's, how many C's, how many A's. So given our sample data, that's what we find. From there, then we want to work in these weighting factors. So how this works is we can see that Group 1 had 1 R and 1 C. So that if we say the R equals 1 times, because you take how many are in the R category, and so Group 1 sensitive, we know that weighting factor is 5.0. So we would just put 1 times 5.0, we know that equals 5.0. The C then, we only had 1 C, so 1 times, that weighted factor is going to be a little bit different. In this case, Group 1 for the common is going to be 5.6. So we would say 1 times 5.6 equals 5.6. We then add those together to get a total value of 10.6. So we want to do that for Group 2 as well. So we had 1 R, so R would equal 1 times, but this time we're in Group 2, so the R weighted factor for this time is 5.6. So we have 1 times 5.6 equals 5.6. We have 1c, so c is going to equal, in this case, our weighted factor is 3.4. So we would just say 1 times 3.4 equals 3.4. And we have 1a would be 1. So it would be 1 times, in this case, that value is 3.0. Gives us 3.0. We then add those together to get 6, 9, 10, 11, 12, 12.0. Then we want to do the same thing for our third category. We just have 1c. So c equals 1 times, in this case, a c value in group 3 is 1.1. That equals 1.1. So then once we have these three complete values, then we want to add them together. So we would have 10.6 plus 12.0 plus 1.1. So that gives us a value of 23.7. So this is our overall value for that index. What we then do is compare it to a table. So that table is also given. So we look at this table here, and we'll find 23.7. So in this case, 23.7 falls into this fair category. So we know based on this other way of calculating that the water quality is fair. So it also goes, we looked at simple, we also had that fair value. Sometimes they'll match, sometimes they won't, but that is in general how you want to calculate both ways. So you have these tables, these values are given. So hopefully this helps. You can also rewatch, go back and forth, re-listen to things to help work through those problems. But those are some examples. So try working through those practice problems, and we will go over them on Monday.